Hello everybody, we continue with problem number 2. Here it is. If all the coefficients in the decomposition of the binomial a plus b over n are odd, prove that n is actually by 1 less than the power of 2 to the power of s for some integer, for some whole number s minus 1, and vice versa, if n is such numbers that all coefficients in the binomial are odd. So let me recall what is the decomposition of the binomial. So if we have a plus b over n, then this is equal to the sum of terms of the form n over k, which is binomial coefficient, and powers of a and b, like a to the power of k and b to the power of n minus k. K is going from 0 to n. So these are coefficients in the binomial, and all these coefficients are odd in our example. So we need to show that this is the case only if and only if n is of the form 2 to the power of s minus 1. So all those coefficients are n over 0, n over 1, n over 2, n over 3, n over 4, and so on until n over n. So let's go from the first one. This n over 0 is n, so n should be odd. Then n over 1 is n times n minus 1 over 2. As n is odd, it is not divisible by 2, so this n minus 1 over 2 should be whole number, and actually, because now this is odd, but also the whole coefficient should be odd, so n minus 1 over 2 should also be odd. And we can go on. This n over 2 is n times n minus 1 over 2 times n minus 2 over 3. And the interesting case will be obtained again actually here, when we have powers of 2 as the lower number in this binomial coefficient. We shall see this soon. So this is again n times n minus 1 times n minus 2 times n minus 3 over 1 times 2 times 3 times 4. This is the general scheme how to calculate binomial coefficient. So n over 4 will be n times n minus 1 over 2 times n minus 2 over 3. Actually, I was wrong. This previous one is also the interesting case. So we now we shall now conclude that this guy here is also odd. Why? Because this is the previous binomial coefficient. This is here, and so it is odd because we require that all coefficients are odd. So it is impossible that this is divisible by 4 or even by 2. So we know that binomial coefficient is a whole number. Actually, we know here that this n over 3 is odd. This guy also here is odd. So it is not divisible by 2, let alone by 4. So this n minus 3 should be divisible by 4. And actually, as the whole coefficient should be odd, this n minus 3 should also be odd. And so on. Continuing in the same way, we will obtain that later on n minus 7 over 8 is also odd, that n minus 15 over 16 is odd. Of course, this number here should be less or equal than n. We are going up to n here. So we can conclude that if all binomial coefficients are odd, then n should be odd, that n minus 1 over 2 should be odd, that n minus 3 over 4 should be odd, that n minus that n minus 7 over 8 should be odd, and so on until as long as a denominator, this guy here, is less or equal to n. So what can we conclude here? We will place n between two powers of 2. Let n be less than 2 to the power of s, which is actually strictly less than 2 to the power of s, because n is odd. N is odd, and 2 to the power of s is even unless s is 0, but if s is 0, this will mean that n is equal to 1, and that case is trivial case. N equal to 1 is trivial case. We have only two coefficients, this one here and this one here, and actually if n is equal to 1, if n is equal to 1, then n is actually 2 to the power of 1 minus 1. So n equal to 1 satisfies the desired expression. So we can assume that 2 to the power of s is not 1, that s is not 0. So because n is odd, we have strict inequality here, and also we will have strict inequality here greater than 2 to the previous power, 2 to the power of s minus 1. Again, if here is equality, that will mean that we have 2 over 0 and that n is 1, the case we already observed here. So in all other cases, we can assume that n is strictly between two powers of 2, like this. And actually, if we now look at those fractions above, which all should be odd, the last one, so we said that this denominator here should be less or equal to the n. The last denominator will be actually this guy here, 2 to the power of s minus 1 will be the last one, this this 8 or 16 or whatever, but the biggest denominator here is this guy here, which is less than n, and the next one is greater than n. And above we have actually n minus number which is by one less. So if we have 4 in the denominator, we have n minus 3. 3 is by one less. So we actually have n minus 2 to the power of s minus 1, but plus 1 because we subtract the number which is the previous number, which is by one less. So we know that this guy here should be odd, because this is actually this last fraction from above, which we claimed, which we proved that it is odd. But actually we will now show that this odd actually means equal to 1, that we cannot obtain any other odd number here but less than 1. Why? Because this fraction here is less than, we now use this second inequality here, that n is actually, we will use this, that n is actually less than 2 over s. So n is less than 2 over 2 to the power of s minus 2 to the power of s minus 1 plus 1 over 2 to the s minus 1, and actually we will now simply show that this is so this guy here is at least 1. This is actually greater or equal to 1 if s is the minimum value is of this guy here is 2 to the power of 0, so equal to 1. So actually this is less than so this is this here is 0 or negative. So the maximum value of this fraction is this first part of the sum here in numerator, so 2 over s over denominator, which is 2 over s minus 1, and this is equal to 2. So this odd guy here is less than or equal to 2, so should be 1. This cannot be any other odd number but 1. So we simply conclude that n minus 2 to the power of s minus 1 plus 1 over 2s minus 1 is equal to 1, and when we multiply this with 2 to the power of s minus 1, we will simply obtain that n minus 2 to the s minus 1 plus 1 is 2 to the s minus 1, and when we put this to the other side, we obtain just what we needed, just what we claimed, that n is 2 to the power of s. Yes, we also need to put this plus 1 to the other side as minus 1, so n is equal to this guy. here. Okay, we proved now one implication. We proved that if all coefficients in the binomial are odd, that n should be this guy here, 2 to the power of s minus 1. Now we are going to prove the opposite claim, that if n is equal to 2, if n is equal to 2 to the power of s minus 1, that all binomial coefficients should be odd. So we proceed as follows. I shall now make some space for that other part. So if we assume that n is equal to 2 to the power of s minus 1, then we simply have that n minus 2 to the power of k for any k plus 1 over 2 to the k. We will now see first that this is odd. Because this is simply, we put that n is 2 to the power of s minus 1 minus 2 to the power of k plus 1 over 2k. So minus 1 and plus 1 we can subtract, and so this is actually 2 to the s minus 2 to the k over 2k, and actually this is 2 to the s minus k obtained from this part, and minus 1 obtained from this one. So this is actually indeed odd if this one is even, and this is even if s minus k is greater than 0. So our claim is true for all k less than s. So for all k less than s, which means that this denominator here is 2 to the power of k is less than 2 to the power of s, and actually because this is equal to n plus 1, so we can go with this 2k up to n. So let me conclude this. Now let me finally see how can we conclude that each binomial coefficient n over k is actually odd. We already know that this is n times n minus 1 over 2 times n minus 2 over 3 times n minus 3 over 4 times n minus 4 over 5 times let me write some more, n minus 5 over 6 times n minus 6 over 7 times n minus 7 over 8, and so on until we reach n here in the denominator. So how to conclude that this guy is odd? We know from combinatorics that this is always a whole number, because this is the number of choices when we choose k subjects from n ones, but how to conclude that this is odd? First, n is odd because n is of this if n is of this kind here. Again, if this is even, this is not even only if s is 0, but then n is 0, which is actually not possible. So n is we assume that n is positive integer. So this is even, minus 1 is odd, so this one is odd. N minus 1 is even, over 2 is clearly odd, but this is odd because we proved here, we proved above that this is odd, that this is odd, that this is odd, that all those fractions which have powers of 2 in the denominator, 2, 4, 8, 16, and so on, are odd. And now we need to conclude that other numbers are also odd. Let me see, this is n minus 2 is odd, so we have no problem with this. This is also odd, we have no problems with this. So for this one is interesting, for example, because this one is even. So why, for example, n minus 5 over 6 is odd? So so actually we need to prove yn minus 5. We know that it is even, that it is divisible by 2. And actually this 6 is 2 times 3, so we can cancel this 2 and with this n minus 5. But why n minus 5 is not divisible with 4? Why is this guy here is not divisible by 4. Because if this guy here is divisible by 4, then also n minus 1 will be divisible by 4. So 4 places in front of, so here we have, and we know that n minus 2, if n minus 1 is divisible by 4, then n minus 1 over 2 will be even, and we know that it is not even, that it is odd. And similarly, we can conclude for other such cases. Maybe I was not completely clear here and completely precise. I lost here some clear conclusion, but I will stop here. It's already too long video here. Maybe I'm missing some small detail here to fully conclude this, but I hope that you understand what I want to say. So thank you. We shall continue with the next video soon.